For this case, we're going to focus on production planning and profit maximization using linear programming scheduling model. So for case problem 1, Vergara Appliance Company is contemplating the production and sales of rice drying mechanism on experimental basis over the next 6 months from July to December. However, manufacturing cost and selling price vary from each month. Also, sales cannot be made in July and they don't manufacture in December. Also, there are operational limitations. The company can sell as many as 100 units per month, but since the warehouse capacity is only hold a maximum of 100 compactors, the operation is limited. And also, the company has no beginning inventory and aiming for a zero inventory at the end of their test period in December. So the goal of this is to determine how many units they're going to make and sell each month in order to maximize the firm profits. So to solve this, we're going to formulate a linear programming scheduling model. So first, we're going to copy the given in the problem, which is given table in the problem, which is the month, manufacturing cost, selling price, production, sales, ending inventory, and monthly profits, since we need to get the total profit. So for the month, we have 6 months, July to December. Manufacturing cost, we have 60, 60, 50, 60, 70, 0. Our selling price is 0, 80, 60, 70, 80, 60, 80, 60, 70, 80, and 90. So since there's still no values for production and sales because they will be our changing variable, then we'll solve the ending inventory. Then the inventory formula will be production minus the sales. Then in another row, we're going to add the first inventory to the difference of the production and sales. So we're going to drag down since it will have the same formula. Our manufacturing cost, change it to dollars. So our monthly profit the formula for monthly profit will be the selling price times the sales minus the manufacturing cost times the production. So with this, drag down since it has the same formula. So to get the total profit, this will be equal to the summation of sum of all the monthly profit. So as we can see, there's still no values for the monthly profit and the total profit because we still not do the Excel solver. So in Excel solver, we're going to click data. In data, we'll choose analyze. We're going to choose the solver. Then solver to set our objective, since the problem is we're going to maximize the profit. So total profit, we'll choose the cell in total profit, then click max since we're going to use maximization. Then our changing variable will be the production, then the sales. So the constraints are given in the problem. First is there's no sale in July. So click the cell in July and equal to 0. Then production in December is also equal to 0. The ending inventory is equal to 0 because the company is aiming 0 inventory at the end of their test period. For the warehouse capacity, less than or equal to 100 as said in the given. Sales limit will be less than or equal to 300. Then let's now move to our non-negativity, which is the production. This will be greater than or equal to 0. Then lastly, the sales also move to greater than or equal to 0. So to check the constraints, we have here. Then after putting all the constraints, we're going to select a solving method. We're going to click here, then choose simplex linear programming, then click solve. So we'll just keep solver solutions. Choose OK. Then we have here the final answer of $22,000. So in conclusion for this is the Vergara Appliance Company is can maximize their profit by strategically producing in a lower cost months. Then selling in a higher cost months, while respecting the inventory and the capacity of their warehouse.
Yan. For this is case 5 problem. You can feel free to pause the video to read the problem. So the required in this problem is use Vogel's approximation. And A is what is the total minimum transportation cost when the company uses only 13 warehouses. Then B, which factory capacity will not be used in 100% under this optimal solution if the company operates only this 13 warehouses. Then find the best pattern of shipments, optimal solution with the lowest cost solution among the three alternative for allocation for the new warehouse number 14. Then we can see the table of the problem. So we have 7 warehouses and 7 factories and 13 warehouses since it is the problem. So how can we solve this? We can solve this using XLQM. So let's close this window, then proceed to XLQM. Then just press this QM. Then it will now open. Okay, so don't show this. So since we are dealing with transportation problems, since it is stated here, unit transportation cost, we will be using the transportation module. Okay, then fleet transportation, then new. We can write in the title unit transportation cost. Okay, since we have 7 sources or 7 factories, then 13 warehouses. Since we are dealing with optimal solution, we will choose minimize. Diba? Optimal solution, total minimum transportation cost. So we'll be using minimization. Okay, so let's hide this panel. Okay. So first, let's change this. Let's change the label to what is the problem. So I already made a table. So we can simply copy paste this for much easier work. Then the 13 destinations or 13 warehouses. Paste. Then next is the values. Copy. Paste. Then demand and the supply. Next. Copy. Then supply. Copy. Then let's paste it. Yeah. Since now we have the values and the labels, we can now proceed to the method that we will be using is Vogel's approximation method, which is yun yung that's the required in the problem, diba? And using Vogel's approximation. Okay. So using Vogel's approximation, then let's click solve. Yan. So now we have the results of the transportation. As we can see, the solution value is $350, which will be our $7,350. Our minimum transportation cost. Then which factory capacity would not be used in 100% under this optimal solution? The company only operates. So we can observe the one that is not optimally 100% used is this Saxton SK. Diba? Siya lang yung hindi na 100% nagamit. So we can simply Saxton SK. So the optimal solution shipment pattern, we can see ito na yan. This is it. Okay. This whole answer. So that's all. Without further ado, let's proceed to the next problem. Thank you.
So, good day everyone. This is Casey, Miss Lim from BSIE 4A. So, this presentation solves this problem 3 using the Microsoft Excel solver. So, this is an assignment problem where 10 astronauts are assigned to 10 missions to maximize the total suitability rating. So, as seen here in this case problem 3, we have a given of 10 missions specialist, which is from Vince to the Trina, and a 10 mission from January 12 to September 19. A rating also from 1 to 10. So the required is who should be assigned to which flight to maximize rating. Second is it has now been received that Anderson is getting married in February and granted a highly coveted publicity tour to Europe for the same month. How does this affect the final schedule? That's why I included here in the given part that Anderson unavailable for February 5 and February 26. Okay. I have prepared here a solver model. I just include this table. It's just the same with the ratings, just on 0 values. And also I have inserted a column summary and a row summary for the total rating. A value of 1 means the astronaut is assigned to the mission and 0 is otherwise. So here, it is still 0 because we haven't done anything yet. And for the objective function is equal to the rating computing the sum for the product of the product. So we have to add here which is the sum of the product. So from the ratings, which is we made here, the tab here, the ratings, and the values usage is B2 to K11 as per mentioned earlier, and that is for the constraint. We have to open our solver here. From home, we go to the data here, and then we just click the solver. So hi again, I just noticed from editing, the video, the pop-up of the solver wasn't showing in the screen, so I just recorded it using my phone. So to set the objective, let's continue. Since we have set the objective here in the end 13, I just press a cell here on 13 and it already showed. And then the changing values of goals would be, let's see, from this to this. So that's B2 to K11, and then we choose the simplex LP, and then let's set objective to max, and then let's add our constraint. First constraint is we want our row summary to be equivalent to 1, since we want also our column summary because we want them to only have 1 assignment per astronaut. So let's have first here, we just highlight the row summary, and then we put equals, and the constraint is 1, as well as for the column summary, we just add equals to 1. So that is for the constraint. So from the binary constraint here, for this 0 inside, let's highlight this B2 to K11, and then let's put this in integer, so that will have the value 1. Okay, add, and then okay, and then we already have a value, a result of 96. So as you can see, we have a total rating of 96. Here are the assignments. You can see here on January 12 we have the Trina, January 27 we have SAST, February 5 Herbert, February 26 Anderson, March 26 Vince, April 12 Yet, May 1 is Moses, June 9 is Brandon, August 20 is Plain, and September 9 we have Certo. So that would be for the part A. And then let's move on to the second part. And for the second part, we have 2 constraints, which is Anderson is getting married in February, and we have 2 Februarys here, February 7 and February 26. So what we will have to do now is we still go back to our data and our solver, and then we add the constraint here. So Anderson on February 5 is equals to 0. And then another is on 26. Anderson is also equals to 0. Let's add. And then we run and solve this. We run the solver. So now, as you can see, we have the result, our total rating of 92. And we can still see here the values. So after restricting Anderson from February mission, and the total rating decreased to 92. This demonstrates how additional constraint reduces the optimal value in assignment problems. And that would be all. Thank you so much.